All right, welcome everybody to the first video lecture of the course Political Science Research Methods 2. Um, I want to discuss, let's say the practical aspects of this course with you today. Having said that, I realize that you probably are seeing a lot of videos and are having a lot of Zoom lectures at the moment, so I do try to keep it short, if at all possible. So I do assume that you have already read the course manual carefully and that you're already familiar with everything that's in that. Of course, if you have questions, we will have a Zoom session where you can ask them, and I will answer any kind of questions you still might have about the course after this introductory lecture and after reading the course manual. So let's get straight into it. What I want to do is I want to give you a brief introduction to the course, particularly, discussing a little bit about the background. And I want to discuss also the course design with you and the philosophy behind the course design, because I think that's going to be helpful for you in completing this course successfully. And then related to that, I also want to give you some very, very practical study tips to make sure that at the end of this period of 7 weeks, you can confidently take the exam and pass this course and get on with your life, basically. And I'm going to be closing up off with, giving you a brief introduction to the first assignment. So let's start with the big question. Why? Because probably you are sitting there or standing there or lying there and thinking to yourself, why? Why do I have to take this course? Which is a good question to ask. Why is always a good question to ask. As a matter of fact, I would say when you start asking why you are becoming a scientist, and given that this is a political science program, well, what do political scientists do? They also ask why questions, which we sometimes refer to as explanatory questions. So, for instance, think about questions like why are some countries more democratic than others? Or, for instance, why are some countries at war with each other while others are not? Or maybe we want to know why it is that some political parties are very much in favor of redistributive policies and other political parties not so much. Or we want to know why some people have more trust in political institutions than others. Or we might want to know why do some people participate in protests while others do not. Of course, these are just a few examples of the kind of questions you will encounter in political science and you will ask as a political scientist. Why, why, why? Now, of course, if you think about how do we answer these why questions, we answer them with theories. So if we are talking about explanatory theories, we are talking about theories that provide a potential answer to our why question. Yeah, so for instance, you could say, well, if I want to know why some countries are more democratic than others, then maybe modernization theory would be a good answer to that why question. Or if I want to explain why some countries are at war with each other while others are with each other while others are not, I might look to something like democratic peace theory as an answer to that why question. Now, of course, it's nice to have a theory. It's nice to have a story about why that might be the case. But at the end of the day, that's just a story, right? So you could say, well, cool story, bro, but is that actually how it works? So good answers to our why questions, good theories, should also somehow reflect reality, right? So if we say, well, our theory basically says that countries become more democratic if they develop economically, then we should also see that it is indeed the case that more economically developed countries are, in fact, more democratic, right? So, in other words, if we want to evaluate how good our theories are as potential answers to our why questions, we need to get empirical. We need to think about, okay, do the observations that we have also reflect the theory that we have? Yeah, so are these two things in line with each other? Now, if we want to do that, we are going to face a very, very big, very fundamental problem. And that problem is that our observations are never perfect and they are never complete. We will never perfectly observe for every potential country at every potential time point, every specific thing that modernization theory says should be the case, every specific measurement of economic development, every perfect measurement of democracy. Our observations are going to be imperfect, and we are never going to be able to observe everything. Yeah, so that's a problem. And why is it a problem? Well, that means that we can't just say, well, these are observations, therefore the theory is correct. We have to make an inferential step. So we have to go from the observations that we can make to saying something about this theoretical process that is underlying these observations. Yeah, that we actually want to know about. Yeah, so we have observations, but what we really care about is that kind of underlying process that is giving us these observations. Sometimes this is referred to as the data generating process, but it's really about, well, we have to generalize from what we observe to basically the theoretical process that we cannot ever fully or completely observe. Now, you might think, well, this is a statistics course, cool. We are just going to make lots of observations, because if we just get lots of observations, then we can make this inferential step with a great deal of confidence. And while that's not completely untrue, there is a very, very fundamental problem with that line of reasoning. Because we cannot prove the validity of our inferential step just by making more observations. Because we will never be able to make all the observations. So our observations will never be complete. So it could always be the case that the next observation that we haven't yet made might give us a different result. So this is formally known as the problem of induction, that we cannot just go from many observations to making general statements about the underlying process that is producing these observations. So that's something that we have to deal with. And related to that, we also have to deal with, well, how we observe the world, what we observe, how we observe it itself is already depending on what theories we have. So, for instance, if we say, well, we are going to look at the correlation between some measurement of economic development and some measurement of democratic development in a particular collection of countries, and to test something like modernization theory. Yeah, that act of saying, well, these are the countries that we are going to compare. These are the observations. This is the unit of analysis that we are going to use. These are the variables and the measurements that we are going to use. All of that itself is already a choice that you are making, because you're saying these countries, not other countries. At this time point, not at other time points, with these variables, not other variables. Yeah, so this is already choices that you are making as a researcher, which means that whatever you do observe is itself already guided by some theory that you have. Might not be a theory that you're aware of or that you have very explicitly in your head, but it is already depending on theory. Yeah, so your observations fundamentally are always going to be through some kind of theoretical lens with which you look at the world. So this is sometimes called the problem of theory dependence of observation. In other words, or in a nice little comic, one of my favorites of all time, this is from the website XKCD, being a scientist means that we have to worry and wonder and ask questions about, okay, can we generalize from what we do observe to what we cannot observe. And in that way, can we say something about theories, about these potential answers to our why questions? Um, now, now we're stuck with a kind of dilemma, right? Because what we say is, well, theories are answers to why questions, and they are good answers if they are well supported by the observations that we make. But we're also saying, well, but we can't prove these theories by just observation because of the problem of induction and because there's a problem of theory dependence. So we cannot ever really justify trying to prove theories through verification. So just taking the observations as a given, and then if we just have enough precise observations, we can say, well, our theory is verified because of these problems. So that way of trying to confront theories and empirical reality is not a justified way of doing that. However, there is a solution to that, and that is, even though we can't prove theories empirically, we can show empirically that they are wrong. By looking at, well, if our theory is true, then we should see some things in the observations that we have. Then we should be able to make certain observations. Yeah, again, this example that if my theory says that economic development leads to democratic development, then if we find that countries that are economically super developed are all not very democratic, then we are able to show that this theory is somehow wrong. Or if our theory is that democratic countries do not engage in wars with each other, right? The democratic peace theory. And then we do actually see in the reality that democratic countries fight wars with each other all the time, then this does prove our theory wrong. And this teaches us something about how good our theory is in answering our why question. So in formal terms, verification is not the way forward, but what we can do is falsification. We can use falsification, so trying to prove your theory wrong by critically confronting it with the empirics that you have, the empirical observations that you have. Yeah. So in other words, what you then do is you say, well, if my theory is correct, then this is what I should be seeing in the data. In other words, you're deducing conjectures, and often these take the shape of specific hypotheses, that can be wrong, that you can show in your data to be wrong, so that can be refuted by your observations. Yeah, so that's the idea. This is sometimes referred to as the critical rationalist approach to science. And that very, very, very flustered looking guy at the top there is one of the most famous people associated with that, let's say, philosophy of science. That's Karl Popper. I hope you have heard of him. If you haven't, yeah, I would definitely recommend getting into some of his books at some point. Okay, so where are we now? We know, okay, we have research questions. Why? Or how can we explain stuff? And we have potential answers to those research questions in the form of theories, explanatory theories, stories about, yeah, it might be because of this or that. And somehow we want to reach conclusions about these theories by looking at observations, by looking at the empirical part. So in other words, we need to make this step from theory through to empirics to conclusions. And well, this is a methods course, and methods are basically nothing more than a set of rules and theories and insights, and that help you doing that help you make this step. So this making this step from a theory through empirical observations to your conclusions. That's really all that empirical methods are for. So what is the goal then of theory-driven statistical research? So the kind of research and the kind of research methods we talk about in this course. Well, the goal is to try to stringently test our theories, to try to prove these theories wrong. So, and how do we do that? We do that by taking these theories and the hypothesis that we can deduce from these theories and translate them into very precisely stated statistical models and assumptions that we make about parts of those models. So that forces us to be very, very clear and precise and explicit about what the connection is between our theory and what that theory predicts about our data. Yeah, so that's basically how that works. And in doing so, we can systematically confront our models and our assumptions with our empirical observations. And we can show, well, okay, this is the model and the assumptions that we can theoretically make. Do they also fit with what we empirically observe? And do that in a very, very systematic fashion. And in doing so, statistics and statistical research allows us to really critically evaluate the generalizability of our findings. Yeah, you might have in previous courses maybe heard this distinction between qualitative research and quantitative research. And sometimes people then say, well, quantitative research wants to generalize and qualitative research does not. I would say that's really not true. Implicitly or explicitly, all empirical research has to deal with the problem of generalizability. Some methods are very, very suited to doing that explicitly. Also, some qualitative methods are very suited to doing that explicitly. Some not so much. Some don't really have a lot to say about that. Statistical research, so what is sometimes referred to as quantitative research, basically is all about trying to critically evaluate our generalizability. So trying to tackle this problem of generalizability heads on, be open about that, and be realistic about how well we can generalize our findings. Yeah, so that's basically the goal of what we're doing here. But of course, that's only going to be working well if you know what you're doing. Yeah, so we can only really critically use statistical research methods and statistical data if we understand how these methods work and how we can apply them and under which conditions we can apply them, under which conditions it will work well and it will work not so well. When can we use different models? What assumptions are we making if we use these different models? What happens if these assumptions are not actually true? What would be the consequences of that? How can we fix that? How can we improve our models? So doing theory-driven and theory testing statistical research requires us to know a lot about statistics. So if you ask yourself, well, why am I in this course? Why do I have to suffer through all this talk about stuff like standard errors and regression coefficients and sampling distributions? Because you care about why. Because you are a political scientist and why questions are important to you. So why PSRM2? Because why? That's why.